Welcome to another stream. I'm your host, as always, Justin. This one's going to be a fun one. This is one of those episodes that has been heavily requested. So I think this is one that y'all are going to enjoy a whole lot. Today we're going to be talking with my good friend Chen. He runs a very fascinating company that is engineering yeast to produce all sorts of interesting things. We've talked about yeast engineering many times on the streams and in videos, and I mean just generally a lot. And so I think this is going to be really cool to talk to someone who is doing this sort of professionally and commercially, and also just making a really interesting compound. So without further ado, let me introduce Kevin. All right, you're live.
We're live?
Yep.
Okay. Oh, there we go. Now I can. Okay, cool. I'm on TV. Hi, everybody. Should I introduce myself first, or how do you want to?
Yeah, go for it. Just start.
Cool. So yeah, pleasure to be here, and pleasure to see you all, I guess, on this nice Saturday afternoon. It's this. I guess Justin asked me to do this a while ago, and I had to think about it a bit, just because I got my own obligations with my company, and this is something professional that I do. So there'll be a bunch of stuff that I won't necessarily get into, and of course, opinions are my own when it comes to talking about a lot of the stuff that we'll get into here. But yeah, we're a company. We're called Hyasynth. We've been around for a while now, since 2014, working on this particular pathway and doing a lot of yeast engineering. We've done some really interesting stuff with this pathway, which we'll talk a little bit about. But otherwise, the whole cannabis industry has been amazing to kind of watch it grow over the past 6 years, and watch the science of it grow, and watch the companies kind of develop. And being in Canada and watching all this happen has been super interesting, just because here, yeah, it's nationwide, legalization or regulation in progress kind of thing.
Do you remember getting the?
So it's been.
Do you remember getting the little card in the mail, saying it's officially going to be legal soon?
Oh, really? I don't remember getting that card.
No?
I
My
mean,
God. I don't know if I saved mine, but I wanted to frame it. I was just oh
yeah.
my God.
Yeah, and that's it's super interesting to kind of watch all this happen, and we'll talk more about the science stuff, but the whole policy around this stuff and everything is also huge, and it's interesting for Canada as a country, nationwide, to kind of create this stuff and kind of force it out in some ways. A lot of people, were pretty reluctant about the whole topic and wanted things to go longer, not go so fast or whatever else. But I guess the government at the time really wanted to push it out, and for many, for many reasons, it makes a lot of sense to legalize cannabis. But anyways, yeah. So pleasure to be here. I thought this was a nice thing to do, just because it's interesting and fun for me. A lot of the reason why I do what I do is because I like to talk and share and promote science and stuff. My day job as the CEO of Hyasynth involves a lot of more business development and finance related stuff, and less so technology stuff. So, if there's any deep technical questions, then I probably won't be able to answer those necessarily anyways, just because I haven't been in the lab in a while. But I do follow all the tech very closely and watch how everything develops. But anyways, I think that was kind of how I first met you, Justin, as well, where we just are people who like to do science, and people who like to share what we do in science,
Yeah.
and that's why it's super fun to kind of be here and spend a Saturday afternoon with all 411 people.
Yeah, I suspect
watching,
there'll probably be more by the end of all this.
Cool.
But yeah, so I mean, so in Kevin's a very cool guy. He does very cool stuff, and so I mean, especially because I'm also working on engineering yeast. He has been a fantastic resource just to sanity check stuff, and just be like, hey, am I going crazy? Am I doing this right? And so that's been really great. So I've got Hyacinth's page open, right? A link to it in the description if you want to check it out. It's a really cool company. They make let's talk about the obvious thing. The stream title says THC, but is THC the only thing that you guys are working on?
No, definitely not. I mean, we like THC is one of 100 different cannabinoids that exist in cannabis. Over 100, I guess. There's a whole bunch of stuff going on there.
We keep finding more too.
And
Like every time we're like,
yeah,
we know all the cannabinoids, and then we're like, oh no, wait, there's a new functional group on that one.
yeah, and it's all the time new stuff. So I mean, it almost I think what we work on is a good reflection of it's maybe a reflection of like how much interest there is around different cannabinoids. So, of course, we read all the papers about new ones coming out, and those ones might be, years away from the market, but it's still something that we kind of put on our radar as like, hey, you know, we'll have some development in that maybe one way or another, depending on how our workflows all come together. There's a lot of
chill for a second. We're having a bit of a
yeah.
stream freeze here. We can get back into it. Okay, so
Okay.
before the stream went to shit, we were talking about there are all sorts of different cannabinoids and also lots of other things that you guys were working on. So let's see if we can pick it up from there. And I'm just gonna try and keep my eye on the thing and see if it freezes again. Hopefully we're good. Hi. So you were saying are you just mostly working on the different cannabinoids and things in that pathway, or are you also looking at compounds from other organisms as well?
No, I'd say we're pretty much set on the cannabinoid pathway. Other things I look at in my spare time just for fun, but
Okay, fair enough.
for business wise, like cannabinoids are yeah. I mean, and that's more than enough of like a industry and market to kind of develop and to work on. So it's huge.
Okay, fair enough. So cool. I'm gonna just bring up my notes and see what the next topic is. Oh, okay. So let's talk about the legality of derivative products in Canada. So we know that the plant is now legal. I mean, there's literally a store down the street where you can just walk in and buy stuff.
Yeah.
But talking about the derivative products specifically, because I remember you were working on this before the derivative products were legal for sale. So like you could still work on them from like a research perspective, but I remember there was like a time when you were still kind of waiting for the government to catch up before the things that you're making would be sellable, basically. So how has that changed, and like do how does that affect your business now, and yeah.
Yeah. This is fun. Actually, I need to block these comments. I'm reading too many of them. They're funny. Anyways, so yeah, with the where we sit with respect to regulations, it's been interesting to kind of watch things evolve over the years. The derivative products that you're talking about is a pretty so I guess in the history of Canadian legalization, first it was like, hey, you're allowed to use cannabis and cannabis oils for medical purposes only and under prescription stuff. And then in October 2018, it was like, okay, you're allowed to now buy cannabis and stuff in a store, and there's like online ways to buy it as well, just for consumers. And then that evolved recently into like you're allowed to now sell like chocolates that have like cannabis stuff in them too, and other things, beverages and like a more broad category of things that contain cannabis. For the work that we do, in general, we're interested in making THC and CBD and other cannabinoids as ingredients. So we're not going to grow anything that would be smokable necessarily, but we might do something that where it could end up in like a pill or in like a cannabis oil of some sort, or it could end up in like other consumer product areas, depending on where we get the most amount of interest. But I hope that kind of explains like what a derivative product is when we're talking about that stuff. It's like anything that's not a cannabis flower almost, and that might be like from a consumer standpoint where we fit the most, where we fit best.
Okay.
But I would add like one slight caveat to that, which is that we might not necessarily see ourselves as a company going having a big role in that direction. It really depends on who else we work with and how we decide to go to market in different areas.
Okay.
And the area where we definitely have like a huge edge in is in like pharmaceutical manufacturing, where you have to have like really strict quality standards, really strict like supply chain, and it has to be really robust to kind of supply people who are actually like using this as medicine.
Right.
And that's where like of course yeast production versus plant production starts to make a lot more sense.
That you're going to be from a genetically modified organism. I think we might be lagging again. Damn it.
Some people were saying it's because of my website.
Yeah, I mean, I scrolled down
but
because
that's actually interesting. I've never heard of that, but okay.
Yeah, the little animation thing was slowing it down.
Right.
Oh man, this is fucked.
The whole website runs off these little animation things. So that's what I mean. You might want to.
Okay, well, so then I'm gonna open up something else. I'm gonna just open this page. Although like now the frickin' Sci-Hub thing is gonna have a little animation too. So.
Oh right.
Yeah, okay, it's still very frozen. Well, this is definitely going to hurt the concurrence, but that's okay. I'm going to just, I'm just going to pull up your face. There we go. See if that does it, if that does the thing. Yeah, I mean, it's kind of frozen. Hopefully the, so it says screen froze audio. Okay, so we're just gonna keep chatting, and hopefully that'll.
Eventually, the video will catch up or something.
Yeah. Yeah. So screen froze audio is okay. I don't know what the deal with that shit is, but we'll figure it out. Okay. So speaking of legality, waiting for the stream video to catch up. But as long as the audio is fine, we can still talk about this. So. The thing comes from a genetically modified organism. So is there extra restrictions, or is there like extra paperwork that you have to do and like testing before you're able to sell your product because of that, or is it still relatively straightforward?
I mean, it always like kind of it's complicated. It's still complicated. And yeah, having a GMO thing doesn't necessarily make it that much more complicated than if it wasn't GMO. Actually, I would say, we've had to go through a lot of different regulatory changes over the years, and let me think. I feel like when we first started out, it was actually easier for us to do it this way than it was for us to try and grow cannabis plants. And now maybe it's a bit more reversed, I guess, from a regulatory standpoint. Okay. And in the end, it kind of varies from every country to country that you're thinking about. And this is like, I think in the old regulations, it actually took a bigger level of permit to grow cannabis plants for research than it did for like chemical synthesis or for biological synthesis of THC, let's say. Nowadays, I think it's all in the same bucket almost, so it's actually maybe a bit easier to work with plants and as easy it is to work with like synthesis and stuff. But then, so in that sense, it was maybe easier earlier. But I guess when I talk about like GMO regulations, that usually comes into play more when we're looking at manufacturing and sales and what you're actually selling, and where you're shipping your strains and stuff, and where you're doing all the manufacturing and stuff like that. Then it gets a bit more hairy. Okay. So especially if you wanted to do.
So yeah, so like if you're selling because I guess you're not selling the organism itself, you're selling one of the products. So like chemically it's the same thing. There's no difference, right? Like like organic sugar and not organic sugar, it's just fucking sugar. But so like if you were selling like a genetically modified corn, for example, that seems like it would be more of a regulatory hurdle than if you're just selling a product from a modified yeast. Because I guess there's a lot of precedent for selling modified yeast, because like insulin and a lot of other pharmaceuticals are made through modified products. I mean, even like rennet is made through like genetically modified organisms. So yeah, I guess that would be a little easier. Like there is that precedent already.
Kind of, yeah. And there's even there's layers of complexity that go beyond that, of course. And this is where like it's it's been it's part of what makes the job fun. Every time you look at a new regulation, it's always a bit different, or every time you look at a new different country, it's a bit different as far as how they might classify one thing or another thing. But I guess one day people will figure it out, and there'll be like more clear regulations for everything. But for now, I guess it's we're paving that road.
All right, fair. That makes sense. So moving on. I guess the one of the big questions is when do you expect to see the stuff that you're making in stores for the first time? Like, are you getting close, or is it still a while away, or like, on a scale of like 1 to 10, 10 being like it comes out tomorrow, 1 being like in 10 years, like where do you figure you are on that?
Somewhere between 1 and 10.
Oh, great. Okay.
I mean, it's actually, it's funny. It depends. It depends very much on the product that we were working with, and which market we end up going on first. And of course, like, I would say there's a reasonably good chance that we'll end up having products available in like Canada before we end up in the US, for example. And there is like a pretty clear route to market in Canada that we can take, and then have our products coming out here, soonish. And by soonish, I mean like maybe within the next like 1 to 2 years kind of thing.
Okay.
But to some extent, again, it depends a bit on, or it depends on a lot of different things that might get us there, and also depends on which product we end up wanting to push that route. Just because each cannabinoid is different, and do we want to have do we want to partner with somebody else, or do we want to do this ourselves, or how do we do manufacturing? And there's all these different kinds of things that sort of have to come together in order to make this all work. So that's the long answer to that question. But either way, as far as what we're able to do now is already like quite good in terms of producing something that you could put to market. So technology-wise, things are really working, and we're really happy with how we've been able to progress.
Well, so I mean, on that topic, yeah. So I guess the big question: have you actually managed it? Because I know there's a lot of theoretical, technical stuff of this is how it could be done, or there'll be companies where they'll kind of pretend that they've managed to do it, and then get a whole bunch of funding, and then proceed to do nothing. So have you actually done it? Like, do you have a yeast?
Yeah, of course. Yeah.
So you've got a yeast that makes the compound, right?
Yeah.
Cool. Very, very cool. Moving on. Let's talk about why yeast is preferred over, say, just growing the plants. Specifically, so kind of from a couple different avenues. Why yeast versus just a factory full of plants? Like what is the biggest, most obvious benefit, would you say?
I think I'm thinking there's a lot of benefits, but what's the biggest one, right?
Well, because I mean, there must have been something if you went down this route, right? Like, what was the thing that really made you think that yes, this is the way to go?
Yeah, I mean, the biggest thing I would say is just having control over what exactly you're making, and all of the processes that are happening in that system to do the manufacturing is the biggest thing. There's other advantages in terms of scale and efficiency, and how you can, of course, put yeast in a big steel tank anywhere in the world, and they'll know how to grow it and stuff. There's a lot of reasons why yeast makes sense. But I think having the ability to turn on and off certain genes to be able to produce one compound or another compound, or to discover new ones, all of those things are maybe one of the most interesting things for right now in terms of growing a yeast over growing a cannabis plant, or trying to breed a new cannabis plant to do something different. Yeah.
Okay. And also, I think it's one thing that's kind of interesting. When we think about growing the plants, there's sort of a bit of a misconception that it's this super green. I mean, pardon the pun, but it's this like green technology where, you know, all you need is just sunshine and dirt and you can just grow these things. But like the reality is most cannabis is grown inside, which means that it's grown primarily using grow lights, which is actually really energy intensive. Like I was reading a little while ago about the energy requirements of this. Specifically, the use case was in Seattle, and as they were moving towards legalization, like the amount of energy that the city was consuming, I almost doubled just to like power all the lights. Whereas if you're doing the yeast thing, like there's very minimal in the way of power requirements. Like it's put yeast in a tank, you know, keep it mixed, add a bubbler. Like you're not you know burning thousands and thousands and thousands of watts on just keeping the frickin' lights on. So there is that little bit of a misconception, and also like all that power generally, I mean, because most places are dumb and don't have nuclear, so it's not like if you you know, if you're running all those grow lights off a nuclear reactor, then yeah, sure, it's you know, it's carbon neutral, but or even carbon negative, but like that's almost not the case. Like it's almost always like natural gas like generators that are powering all of this stuff. So like it's very energy intensive. So I guess in that regard, like the yeast thing is kind of good because you can also rely on the like tried and tested technology of essentially it's making beer basically. Like that's like it's making beer, except the end product isn't the liquid, it's the, you know, the stuff that settles out to the bottom. Like that's really the difference. And like we've spent a lot of like thousands of years basically making like perfecting the art of making beer. So it's like there's that you know precedent of like we know how that works. Like you get a big tank and you do the thing, and you know, and also like, you know, depending on, so we were talking briefly before we got started about what you're actually using to grow the yeast. And so something that you'd mentioned was that right now you're using kind of like the ideal growth media, but potentially in the future you could use things that are less ideal but maybe cheaper or more environmentally friendly, or, you know, maybe like offshoots from other production of stuff. So can you tell me a little bit more about that? Like what are you using? I mean, I know you probably can't get into like super specifics,
Yeah,
but
the secret sauce.
yeah, so I know.
Sorry.
Yeah, I know you probably can't tell me the secret sauce, but like in essence, it's basically sugar water. Yeah, it's like sugar water with some nutrients.
Yeah, I mean there's all kinds of different ways to grow yeast on different kinds of media, and you can have really fine control of all the different components in like your media composition, and part of that is what will give you like more or less maybe yield of product too. And so it becomes part of like the game is to figure out how all these different things and do the science and do the research to figure out what the best thing is, and get there, I guess. But yeah, you're absolutely right about like, you know, growing cannabis being like kind of more expensive process. It's not grown like the same way that a lot of other agricultural crops are grown that are a lot cheaper to grow, of course. And as far as future goes, I mean, yeah, we already talked about this, but for the sake of the audience, yeah, once you have a yeast that does this, you know, yeast can continually be engineered and optimized in different ways, and that could lead to a lot of improvements when it comes to the efficiency or environmental friendliness or sustainability, whatever cost of the whole thing. Yeah, that's part of the, you know, among the many reasons why this is like an interesting technology, and why we're doing this, is that you can, you know, actually have these futures exist, whereas you can't just kind of like, you know, suddenly get a cannabis plant to start, you know, consuming a different substrate, you know, overnight. Whereas
right, like plants are plants, like they're sort of set in their ways. Like engineering a whole plant to do something different is, I mean, it's much more difficult than like tweaking a gene or two in some yeast.
Yeah.
So actually, speaking of that, so the idea of like, okay, so being able to grow THC in a tank, obviously has its benefits, and it has its immediate scalability. So why couldn't you say, because like suspension culture, for example, exists for plants, right? Where you can take a little tissue sample, and then grow the plant essentially in a liquid, where it doesn't grow as like plant, it grows as like tank of weird green soup. So why couldn't you do that for cannabis, for example?
Um, I guess, I mean, I won't say never. Like somebody might figure this out somehow and get it to work properly. But generally speaking, like we like yeast because it grows fast. You can replicate it quickly. Plant cells are, you're taking them out of like the normal growth environment and trying to grow them in these fermenters. And then that's where like you do have to do a lot of special things to the plant cells to make them grow that way.
And the media is
And in the
expensive,
case of,
like really expensive.
yeah, I mean, I'm not like a plant cell culture expert, but it's, you can look at different products that are made from plant cell culture, and I think they end up being like, hundreds of thousands of dollars a kilogram versus like, tens of thousands of dollars a kilogram, for example, or millions of dollars a kilogram kind of thing. Um,
You also
so
need. So I've done a little bit of plant cell culture, and like the plant media usually is composed of what's called Murshig and Skoog base, because biologists are shit at naming things. But also, it's a lot of sugar. So like you still need sugar. Like it's instead of just yeast, where it's like sugar and a nitrogen source and some air, basically. I mean, like wine, like a tube of wine nutrient, for example, for like growing yeast, like you need like the tiniest little bit per gallon of liquid. Whereas for plants, like you need the Murshig and Skoog, and then you need the buffer, and then you still need the sucrose. So like it seems like you're kind of cutting out a lot of the middleman with the yeast versus trying to do it with plants.
yeah, and I guess the other idea that's important is that when you're growing, like the cannabis plant grows and it produces THC in its trichomes, and that's where it kind of accumulates, the ingredient, right? So you end up with these big flowers on the plant that's where the product accumulates, and that's like a physiological property of the plant that's like super super interesting. But to get a plant cell to do that exact same like effect in the cell culture, then you end up with like a much like harder situation, because plant cell culture, you got like, yeah, just sugar cells, they're all like floating around there, and it's not the same environment as like, of course, a cannabis flower, right?
And
um,
yeah, from some of the reading I was doing, like they don't, like when you grow cannabis in suspension culture, it doesn't even produce THC. So you'd have to engineer the thing anyway to get it to be producing the compound in an organelle, like in an organ of the plant that it normally doesn't, in cells that it normally doesn't. So it's like a huge engineering challenge, more expensive media, and it's finickier. Like if something gets in there, it gets contaminated, the whole batch is fucked, and then you get to start again. And it's like, so it really does seem like when it comes to, if you really want to grow THC in a tank, like yeast really does seem to kind of be the way forward. Although I mean, then there is the question of like why yeast, right? Like if you just need a microorganism, why yeast versus say bacteria or algae?
yeah. So there's a whole interesting bunch of questions that come along with that, and it really depends on maybe the product that you're making, and that's where like I could argue that for some products, plant cell culture makes perfect sense to manufacture the thing, but it really depends on the product and the cost of it and the complexity of the actual pathway and everything like that. But this is also like part of the reason why you can choose which organism you want to do. In many ways, yeast is great because it's easy to engineer. It grows fast. It has a lot of different kind of metabolic parts you can play with, and you don't see as much of that in like other kinds of bacteria or in algae or whatever else. You have to you might have to fight harder to get it to like take up different genes. You might have to fight harder to get some of the genes to actually like function properly in different cell types, and or you might have to like do more engineering with the metabolism to get it to like do the right thing that you want it to do.
Right.
And
So
there's more questions beyond this, but like yeah, growth rate and how it reacts to different products being made and how well it makes different proteins, and you can get into this like fun and complicated science of metabolic engineering.
and I mean, I think there was something important that you mentioned in there, where it's like basically, like, yes, you could express the genes in sort of whatever organism you want, but it's not enough to just have the genes there. Like, there's, like, all pathways require feedstock. So if you can't also mess with the genes that control the feedstock, you might, like, have great expression of the couple of genes you want in, like, E. coli, but if they don't have the ability to produce enough feedstock, it kind of becomes a moot point, where, like,
Yeah.
you're just not going to get a very good yield, even if you can express the genes just fine. Like E. coli are very easy to get genes into, but if they're missing the like base metabolism to get you the stuff that you need for them to even work, like, your yield is going to suck.
Yeah, yeah, and that's like, I mean, so many. That's where it gets to be like, yeah, pretty complicated, interesting science. I mean, it's part of the fun of the scientific job, I guess.
Right.
And you can have a whole 2 hour session just on that or something like that, right? Um,
Right. So there've been a couple of questions asking about the pathway. So we'll get into actually talking about the pathway in a little bit. I just wait. I've got like a list of questions that I'm just kind of working my way through. So once we've kind of talked about all the background, we'll talk a little bit about the pathway closer to the end. Because I mean, it is a very interesting pathway. There's some like really interesting chemistry in there that I'm excited to talk about. And also, I'm going to be showing. There were some comments about the Sci-Hub link. Like, you provided a paper that from a different group that is doing this, and you know, one potential pathway that they're using. Because I think one thing that it'll be important to talk about later is that, you know, there's many ways to skin a cat, right? Like, you can get to the same end product chemically through very different routes. Like, there might, and you know, one route that might be easier to engineer might not necessarily have the best yield, and that kind of thing. So we'll talk about that a little bit later. Let's just kind of keeping to the you know, talking about the industry and the, like, kind of business aspects of this, because I mean, really, like, at the end of the day, the only thing that makes any of this work is the fact that, like, you've got the, you know, money and backing to do the thing. So where do you see the industry going? Like, this, I mean, this is a very new, interesting take on the thing. The industry, I mean, in Canada, within the first, like, weeks of them opening the industry up, made millions and millions and millions of dollars. So, like, where do you see the industry going now that things are becoming more legal, and more products are available, and all this kind of stuff?
well, yeah, for starters, all the products are going to be made by yeast one day. There won't be any cannabis production going on anymore very soon. People will still want to grow cannabis in the future someday. But there's, I think that, I mean, the industry as a whole is, where do I start? So one of the interesting ways to think about the industry is, you know, looking at the alcohol industry or the tobacco industry and see how those have gone or are going, and see where cannabis, like, could head eventually. And you could draw all these, like, interesting cultural comparisons between, like, all these different things that exist. I mean, as a whole, it's like a lot of interesting questions that, like, you know, everyone has to ask for themselves culturally, and also, like, politicians have to figure out, like, how do they see this unfolding, and how do they see, you know, legalization existing or continuing to exist, or do they see it growing or not? And what else? You know, it's I think one of the cooler and more interesting ideas about this stuff is that, you know, it's this industry that's coming from this very, like, taboo black market into, like, this legalized market. And if you think about, like, you know, the way these compounds actually work, and how beneficial they are or how not beneficial they are for different, you know, cases, and compare that to, like, you know, alcohol, for example, then, you know, you could argue that the health impact of alcohol is a lot worse than the health impact of, like, you know, cannabis related stuff, or those compounds that are there that are interesting.
Right. Well, I mean, like, alcohol kills literally millions of people per year, whereas I think cannabis has killed zero. So, like,
Yeah, I mean,
and
that's like maybe
and
part of
also,
the whole
like,
story.
the only reason that, like, cannabis was illegal in the first place was racism. Um, like, yeah, back, I mean, was it Nixon? I don't remember, but the whole war on drugs started as a way to basically shut down like government dissent because they knew they had nothing on the protesters. So they're like, well, if we can just make their
Right.
so it's been
Hey,
very.
you've been watching what is it, Netflix, the 13th? Is that the documentary where they really?
I haven't seen it.
Do you
No,
watch that one?
no, I
Oh, you
haven't.
haven't seen? Okay, it talks about this stuff, which is super. It's actually super cool, but yeah, I recommend watching it if you
Okay.
haven't. But yeah, you're right. You're right. It's like this interesting set of laws that came about, which didn't necessarily have a solid basis of like reasoning why, or it's just like general,
Yeah.
fear of stuff that people wanted it to go one way or another, right?
Yeah. I mean, I remember back like while I was in university, just having like casual conversations with people who were like really against cannabis. Like they're just like, no, it's evil and we shouldn't. And I'm like, I wish, but at the time I didn't know that the whole reason it was illegal was because of racism. So like, I wish I'd had that like little bit of tidbit to be like, oh, you don't like it. Why? Well, it's illegal. Yes, but why was it illegal? They're like, well, because it's bad for you. No, it's because of racism. So that's a thing. Yeah, I mean, personally, and this is totally just my opinion. I think the war on drugs is really fucking stupid, and like, just it's dumb. Like it exists basically as a way to funnel people into prison, and then use them as slave labor. Like it's really fucked. And it doesn't hurt anybody. Like someone smoking some pot is not gonna hurt anybody. Like there's definitely a conversation to be had of like it's not the like magical cure all that people pretend that it is, and like it definitely has health effects. Like it can totally fuck your lungs up and that kind of thing. But it's also not the like evil boogeyman that it's often made out to be, especially by what's the best way to put this? Uh, older.
No politicians in the 70s or something like that, right?
Well, except it's
I
not
don't
even in
know.
the '70s. It's still
Or
like
earlier, yeah.
like politicians still think like love to demonize it as this awful, um, like horrifying thing when it's like it's just a plant. Like, chill.
And it's cool. I mean, the cool thing is like how many people maybe are being convinced now of the opposite, and the way that this is all being reconsidered, where it's like, you can actually ask the question like, how dangerous is this really, and actually have science back up some of these things, and that's part of the cool things that are happening in this industry, and now that is even being like the leading edge of these kinds of thinkers are starting to do stuff like, oh, we can do like clinical trials with like MDMA or psilocybins and treat PTSD and start to push things in that direction too, which is really really cool because you're starting to see these new medicines that are being considered, which whereas in history they would not have been considered at all because
Yeah.
of the legal taboo around them. And so we're seeing this like nice wave of stuff in cannabis, and even more like newer waves coming in like other areas too, which is exciting too.
Yeah, and I mean on that topic, like there's other plant or well organism derivatives because I mean a fungus is not a plant, but like there's all this fantastic research on how like psychedelics can be used for like really serious benefit for people with depression and all this other stuff, and obviously like I I always like to put the little asterisk on that one where people get a little bit too excited about this, and then like that becomes their only thing. It's like okay, like you still probably could use some antidepressants, but the fungi are good too. Um, but
Or you look at the opioid crisis as like another case example where
yeah,
like that's something that was, pushed legitimately by like industry and then turned out to be like the worst thing ever, right?
yes,
Like you
and
can
we still
legitimately ask
can't
these
seem to
questions
put
like,
them
do
in
we?
prison for it. Like
Yeah, it's really crazy, right? So it's this funny. So it's nice to kind of see these stories come out and be open and be like popular stories, and people can kind of like look at those and say like, oh yeah, we did that wrong, very obviously, and now we can think differently about things, which is nice.
also, there's
Yeah.
been some really interesting research on in areas where they've made cannabis legal, like the use of opioids goes down because people have other methods of. I mean, because it's not magic. Like it doesn't just like make pain go away perfectly. Like that's not how biology works. But I mean, when it does make it better and more tolerable, and so like there isn't necessarily as much of that like need for like narcotics. So that's been really interesting, and I'm excited to see kind of how that continues to develop. Um, especially in Canada, where we're essentially becoming this like really fascinating use case. Although I do find it also very funny when, like, so in Quebec, for example, like they tried to make it illegal to grow the plants yourself. Like you could only get it from, and they always make the same stupid justification, like we need to protect the children. What if the children get into the plants? I'm like, well, then you're with the fight. Then you like, first of all, what child goes around just like chewing on the plants? Like, if your kid does that, you have bigger problems. Because if they're doing that with like a cannabis plant, oh, they're gonna have a real exciting time when they try that with anything that's outside. Like they're going to die.
Yeah.
But for people who are not familiar with this, the federal government set it so that each individual province could set how many plants you're allowed to grow, and Quebec, being fucking Quebec, decided to be dicks about this and decided to set that the number at 0. But this was struck down by the Quebec Supreme Court, where they're basically attempting to make something illegal, which the federal government has explicitly said is legal. So because they tried to be dicks, when the law got like undone and it got set to the federal maximum. So instead of just like being, kind of conservative about it and be like, you can have 1 plant, they tried to be dicks and now it's 4. So like I find that deeply entertaining. Like, because I mean the people who are in, and I mean this is getting into all the politics and shit, which is not particularly interesting, but the people who are in charge in Quebec are dumb. So they're very, they've got that like old school stance of like all drugs are bad, and also they're fairly racist, but that's another problem for another day. But yeah, so that's been very interesting. And also it like they'll make the excuse of like, we're trying to protect the children, when in reality it's like, no, they just want to have a monopoly on the sales. It's most of what it is. But anyway, so that's that. So let's move on from the kind of like politics and vitriol, because as entertaining as I find it, it's probably not super interesting to listen to.
Yeah, you can have a different guest, different channel on just for that.
Yeah, right. I mean, I could have all sorts of people just to like shit on the government. That's it's my favorite thing to do. No, okay. So moving on. So actually, well, speaking of the government, are you preparing for the eventual legalization in the U.S.? And are there other countries that you're also eyeing? Because I know there's like in like the Netherlands, like there's some amount of it's somewhat legal. Like, so are you looking at other markets outside of Canada, or like what's your take on that?
Yeah. Short answer is yes. Definitely looking at markets outside of Canada. And that's one of the nice things about a yeast system, is that there are manufacturing facilities outside of Canada that you can leverage to do this very quickly. It really,
like everyone drinks beer. Like everybody drinks beer.
Well, I guess we'll talk. Maybe we'll get more into that later, and why it's different a bit. But either way, the beer side, there is manufacturing facilities that exist like all around the world that do this kind of stuff with yeast and production. Yeah, a lot of different directions we could go. A lot of different regulatory considerations for each different country, and definitely, yeah. I don't know what will happen in the U.S. Like, we'll see how that goes. I think I haven't heard too much recently about who's the next one pushing for like cannabis-related legalization stuff. But there's been a lot of activity there, and of course now I think the majority of states have at least some like legal access to cannabis. And maybe that's the way that it'll go. It'll just be that all the states legalize, and then eventually a federal government has to make a decision. But it's all interesting and exciting stuff to see who will do what, and there's even some like finer differences between like whether you're looking at like THC as the product or as like CBD as the product, and then whether you're growing like hemp or whether you're growing like cannabis, and then it also gets a bit funny. Right. But yeah, a lot of interesting, a lot of doors that are opening.
Very cool. Very, very cool. I mean, personally, I look very forward to seeing it all get legalized in the States, just because I mean, kind of getting back to the politics, it's like, it's just funny watching the like old stupid politicians being like, this is bad, whereas like I think it's the like a significant majority of Americans are like, no, this is fine. The fuck are you talking about? Like, so that's been very interesting. Okay, so let's get into some of the more technical aspects of this. And fingers crossed that as soon as I tab off of Skype, that the stream doesn't just shit the bed. Um, but okay, let's start with the simplest, because it was something that you sort of just mentioned. When it comes to actually growing the yeast, like what does that look like? Like, so I mean, it's some flavor of bioreactor, I assume, but like what does that look like? Is it a big steel tank? Is it smaller little reactors? Like how is it and like is it going to be grown in like a large batch that you then harvest, or is it something that you're kind of constantly pulling off small amounts of the yeast and media? Like how are you looking at that? Like what's the, because I mean, like you said that it's not like growing beer. So growing beer, you do it as big batches. So I guess you're doing kind of constant systems.
Not necessarily, and that's something I'll defer to, like, you know, uh, it's process development. It's like a workflow that you try to figure out like what's the best way to make something, and maybe it is by doing a batch, maybe it's by doing a continuous like extraction process. There's different ways to go about it, and it's a lot of stuff that might become like trade secret stuff or become patentable stuff one day. So I won't get too much into like exactly what we're doing, but it is fundamentally different than like growing a beer yeast where you're trying to get it to produce like ethanol, and you have like these maybe somewhat similar kinds of feedstocks that are always being used there. So I wouldn't say we could. I would say like our manufacturing will look a lot more like insulin manufacturing, right? Where it's like a big steel tank, very sterile conditions, very controlled environments, very controlled like media and all this other stuff, and less like a beer fermentation. And that's like unless we really want to go that way, but I don't think so.
Just really quickly, we just had a donation from Monstead. He says I couldn't afford 420, and $4.20 seemed a little bit too low, so he donated $42. So thank you very much, Monstead. Greatly appreciate it.
Cool.
So getting back onto it, I'm gonna see if I can pull up some images of what an insulin bioreactor looks like. I am very sorry if this bricks the stream, and if it does, we'll switch back to the Skype view. So bear with me if this bricks, but assuming that it doesn't, then it'll actually let us look at some more images. Not that. Also, I just noticed that you've got a Spira card thing in the background.
Yeah.
Which fuck yeah! Shout out to Elliott Spira and Elliott. Both do very cool shit. We talked about him on the last stream actually. So okay, let's pull some stuff up. So this is the paper that you linked to me, and it says the complete. So the name of the paper, for those who want to follow along, is called The Complete Biosynthesis of Cannabinoids and Their Unnatural Analogs in Yeast. So, I mean, it's exactly what it sounds like. It's using yeast to make cannabinoids, and included is a wonderful little biosynthetic pathway. And I mean, it's definitely complicated. Like, it's not a one enzyme and then it just happens kind of thing. Like, there's a lot of different enzymes in here. I mean, you can even see that on the some of the on like one side there's like 1, 2, 3, 4, 5, 6, 7, 8. Like, there's like 9 different enzymes just to get to like one of the initial feedstocks. So like it definitely has its quirks. But I mean, the main thing here is basically you get to 2 different products, so GPP and OA, and we'll talk about those each in a second. I'm just trying to keep out of the corner of my eye to see if the stream is lagging, and it doesn't seem to be, so I think we're good. Okay, so obviously the route that your company is going down is potentially different than this. Like we said earlier, there's lots of ways to skin a cat, which is a very weird expression when I think about it, but don't skin your cats. Leave them as normal. They're cuter that way. But so this isn't necessarily the pathway that you're going for, but it's one example pathway. So to me, the things that really stand out here are first off GPP. So GPP is actually something that we've talked about in many streams before because it is sort of it's one of like two compounds that basically act as the feedstock for most, or not most, but many different metabolites. So I've got a window pulled up over here, so this is hopefully not going to break the stream again. But so for example, I'm gonna move your floating head here. So GPP is geranyl pyrophosphate. Um, Basically, the way that like yeast and plants and this sort of thing will go about making compounds is very different than the way like we would do this in like a flask in a chemistry lab, right? So just the thing that I've got pulled up here, starting with this one initial compound, like you can make literally hundreds of different compounds depending on which enzymes act on it. So the fact that THC is made from GPP is actually, I find, fascinating, because it, like I said, it's something that is, extremely ubiquitous in biology. So in this case, it's GPP and OA, and so the OA is olivotonic, olivetolic acid. Fucking biology, it's hard to pronounce things. But so again, this is another really interesting example of there is absolutely no reason that we would ever do this way in a flask. But like in a biological system, it makes a lot of sense. So you can see that it's this really weird, long polyketide, this being the ketone unit, polyketide that gets cyclized into the aromatic group. So in this case, you've got one long, weird compound that ends up with, aromatic on one end and a dangly hydrophobic bit on the other end. And then when you combine these two, so like once you've got GPP and OA, like is just off the top of your head, do you know if OA is present in yeast normally, or is that something that you've got to add?
So OA is not present in yeast normally.
Okay.
Yeah, definitely have to. That's the first recombinant step, I guess.
Okay, so that makes sense because I know GPP definitely is. So okay, cool. So you'd have to. So I guess the orange is probably stuff that is already in the yeast, whereas blue is stuff you have to add. And you can see that it all starts from acetyl CoA, like or like hexanoic acid. These are both like fairly basic, simple things. We actually looked at hexanol in stream very recently. I think it was last week before. So but just to be able to get to this end product, because you need this thing, you've got to make this whole pathway work, which, I mean, that's a lot of enzymes potentially. So I mean, I like we said, like obviously you can't comment on the exact way that you're going about it, but like already just to get the process going, this is 1, 2, 3, 4, 5, 6 enzymes just to get this first feedstock here. Like that's a lot of engineering just to get to this point. So it's I just want to convey like how potentially difficult the thing that you guys are doing is. Like there's a lot of work that's got to go into making these things work and function, and just to make the end product. And so I mean, it seems like a fairly simple step once you get to this point. Like you've got your GPP, you've got your OA, and it just looks like it's two enzymes basically, just to get to either THC or CBD. And this is also kind of cool. Like you can start with these same two feedstocks, and just changing one gene dictates what your end product is. So I think that kind of leads into or harkens back to something that you mentioned earlier, where changing one or two genes lets you tweak the end product. And so you can get these two very different, very valuable products using only a small amount of modification, like once you've got the initial stuff set up, which I find that very cool. And I mean, by the looks of this, these are both the THC or CBD A, and you can see that I'm going to make this a little bigger just so this is obvious. You can see that there's a little T here. This is not an enzyme. This is just heat. like good old fashioned heat. So yeah, just kind of interesting, and which to me I find this interesting because that's the exact same thing that happens in the plant. Like when you, like if somebody is like smoking the plant, for example, that's where that heat is coming from. So it's like it becomes the active form when you heat it, not necessarily in advance. So I just find that interesting. So I guess actually that raises an interesting point. Are you gonna have is one step in your process? Like say you decide to make your product into a pill. Are you gonna have to like roast it at some point? Like to do that conversion? Like is there gonna be a cooking step? And like do you expect that to mess with your yield a little bit? Like because I mean as soon as you're heating something, like you're definitely gonna destroy it a little bit. So, like, is that something that you're already kind of trying to account for?
Yeah, it's part of the process overall, I'd say, and something that also needs to be looked at. Hmm. Uh, yeah, you're gonna have to deal with that one way or another.
Okay.
No, I get like there's something else that we've got going on that's like maybe gonna like find an interesting way to cut around that, but
Okay.
I won't get into that. But basically, yeah. I mean, when people make like cannabis oils, for example, like you're extracting from the cannabis plant, and then you're ending up with like a THCA in this like oil or whatever, and then you have to heat that to get it to be like decarboxylated, and then you actually have the active ingredient in the oil. Because normally you smoke cannabis, right, and that's where it gets
Right.
decarboxylated.
And like if you're making it edible,
yeah.
like it gets decarboxylated. I mean, a lot of people will do it before they even start the cooking process, but a lot of the time it just happens in the cooking process. So it's like at some point you got to put that energy in there to like knock the bond off.
Yeah, I guess so. And there's a lot of actually interesting things beyond that when it comes to like using just THCA and CBDA in their original forms as like maybe more like therapeutic products. But usually when people talk about these compounds, they're talking about THC and CBD as being the ones that are the active, things that people really want to use that will have like kind of an impact, right?
Right.
But you might even be able to find more things beyond that.
Huh. Okay. Well, very cool. So actually, speaking of this, like, and I mean, of course, you're free not to answer if this is, but is there like, because I mean, THC and CBD are the like really famous cannabinoids, but is there another cannabinoid that you find particularly interesting, like something that you're thinking of maybe pursuing one day, or has interesting properties? Like, are there any that stand out? Is basically what I'm asking.
Um, Let me think. There are many that stand out. Actually, maybe I'll think for a second and then come up with something that
All right, fair enough.
is maybe more specific. Um, but let's see. I mean, if you want to look at something interesting that's worth talking about is like a recent publication with a compound called THC. They gave it a name, which is a bit silly, but THCP, I guess. Which
I'm always
is,
terrified of Googling these things because you never know what's going to come up.
Yeah. Hopefully you'll get this paper, which is talks about this compound, which is a slightly different variation on THC that apparently had some kind of like higher affinity for like the receptors, which doesn't necessarily mean it's going to be like better or worse than THC originally was. But it was like kind of a funny headline to see that come out and then like be like, oh, that might be like an interesting thing, and then, but in reality, if you know enough biochemistry, you'll be like, oh, cool, that's nice to see that they've proven that in like cell lines and stuff. Maybe that'll translate to humans, and then it could be an interesting target. But do we actually need a stronger form of THC? Like maybe not. Maybe we're okay with the regular form of THC or something, right?
That is really interesting. That like it does the same thing. It's just stronger. Like
yeah, and actually, if you want to get into like the history of this whole like industry and the perspective of like compounds that are stronger or weaker or whatever else.
So is this found in the plant? Like is this synthetic?
This is found in the plant.
So you could.
I think this is one of the recent minor cannabinoid discoveries.
So like you could breed the. I mean, this would be a shitload of work, but like in theory, you could breed plants for this, because I know that like the actual biochemistry of the plant itself. Like there is a hard threshold of like how much THC you can actually get in the plant before it just dies. So like I think it's about 24-25%. The plant gets real sad at that point. Like it doesn't like it.
Yeah.
So I guess that raises a really interesting possibility of if you could breed this stuff and select for this rather than the traditional THC, you could get more potency in the same amount of like gram for gram worth of stuff, and kind of surpass that strength threshold, which sounds kind of fucked. Like 25% cannabis is already very strong. Like you'd have to be like have a heroic tolerance to be able to even like deal with that casually without it just knocking you on your ass for a week. But hyperbole obviously, but like that's a really interesting concept. And like as people like, especially now that it's legal and people are able to study this more, that it'll open up these like new discoveries of like, hey, maybe we've been selecting for the wrong cannabinoid all these years. Maybe there's something better. So that's really interesting. And I think it's just it's just like one difference of bond. Like it's a trans instead of a cis bond or something. Like that's wild.
You could get into, actually I have two things to say on that. One is that it's a fun thought experiment to think about, like why wasn't this compound not already selected for? And if you look historical of like use of cannabis, like people say like, oh yeah, cannabis used to be so much weaker like years ago, and then people selected for it, and now you have like these high THC strains or whatever. But why was THCP not the high THCP strain or whatever? And I guess that ties back to like some fun, maybe there's a evolutionary geneticist watching and who can dig into this and figure this out or something like that.
I wonder what this
but I guess it
reminds me of like Brussels sprouts, like how Brussels sprouts used to suck, and then people kind of went back through all the old heirloom varieties and found ones that were not gross, and so like those became suddenly. This is why like there's been this weird renaissance of Brussels sprouts. So I almost wonder if that would happen with this compound. Like if people start going back through the old like weaker strains, finding one that's much higher THCP content, and then just like using that as new breed stock. Like that could be fascinating.
Maybe, but this is my other point.
Okay.
There's a big asterisk there, which is that you don't want to mess with this system almost in that way. And if you look at the history of the endocannabinoid system, I guess, and you can Google around like all the drugs that came out for the system, and basically, long story short, there was a compound that people tried to develop, which is for weight loss and for obesity, and it did hit like the same receptors that THC hits, and it hit them pretty hard, and it's kind of like optimized for that almost. Like it's one of these designer, when you look at the structural biology of it and you design these things, right? And what ended up happening is that drug got to market and then got recalled and eventually cut out, I think, altogether, just because it was one of the big side effects was like really hard depression and suicidal thoughts,
Jesus.
kind of thing.
Okay.
So you can look up the story. It's the project is called Rimonabant, and I think it was Sanofi that was the one working on it. I don't want to get into too much of the complications of how big pharma works, but basically, you don't necessarily want to have this compound exist and have it be the main driver of this industry, because you might start to see those kinds of things.
Right.
And that also gets into this argument of like the term like synthetic cannabinoids, which are like chemically synthesized compounds that are hitting the same receptors, but they're not THC, they're not CBD, they're not coming from plants, they're just these new compounds. And that's where like, you have these stories of like, I think it was the bath salts stuff that was like hugely controversial, and these sort of new black market drugs that are coming out and causing all these problems. So,
I mean, THC is good because of the history of it. Like there's literally thousands of years of safety data, in the sense that like people have been using it for thousands and thousands of years. Whereas all this new stuff, you don't have that like historical precedent. So yeah, maybe THCP is way stronger, but like you say, it could have horrifying side effects that maybe that's not what you want necessarily. So that's really interesting though. But I mean, it could be.
So,
but I look forward to those clinical trials. Like,
Yeah.
because like,
But this is also the most fascinating, one of the so interesting things about this, the endocannabinoid system thing, right? It's like this system of receptors that, does, it seems like it has its hand in a lot of different things related to like human development, related to like psychosis and all this other stuff, obviously. But it's still, people are still trying to piece together these different receptors and how they all work together and whatever else. It's not like a super simple system. And for example, like CBD, people like CBD doesn't hit these two. Yeah, you're looking at I guess I'm looking at the live stream, but I know this is like a few seconds behind, so I'm like, I don't know where we're at now.
I'm just
But
scrolling
CB1
around.
and
I'm not
CB2
really looking
receptors.
at anything
Yeah.
specific.
CB1, CB2 receptors, if you look at those receptors and like what hits them, it's not like if you hit the CB1, CB2 receptors harder, you're going to get more or high or whatever. You might just have like, worse things happen.
Yeah, sometimes shit just breaks. Like,
yeah.
like-
And then you just have like these stories of people using cannabis for things. That's why it's like this weird backward stuff happening with this plant and what people are using it for, and how that might one day become like mapped out from like a receptor standpoint. But for now, it's still a lot of science that's being done, a lot of figuring out like how each compound works with which parts of the molecular biology in humans that it's hitting, and it's one of the big challenges. And if it was a simpler system, then like you might not even have as much attention towards this stuff, but because it would just be solved kind of quickly maybe. But anyways,
right. Well, I mean, it's fascinating. Like,
yeah.
and I mean, this also like that really does touch on the like. I mean, so I took a like a pharmacology, like pharmacokinetics course at one point. Also, just we've had a couple of donations that are like 420 themed, so somebody donated 420 rubles. So thank you. But so and it was really interesting that like, there's a few main like targets for drugs generally, but it's these tiny little changes can be like the difference between something working really, really well and also having horrible side effects. And especially like when you get into the like generic versus like the original thing, like sometimes they'll just like stick a functional group on a compound, and technically it is equivalent. And so they can, there's basically like these weird examples where if you stick specific functional groups on things, like you can just barely shift it enough that it's not patent protected anymore. And because it's so similar, the amount of clinical trial that you need to get it approved is way lower. But because you've added this functional group, there is the chance that like it might have been really important, and like it can have wildly different effects. And so like that can be really, really tricky, and that's why some people will have really unpleasant side effects when they switch from like the name brand to a generic. So that's really interesting. So we just had a question. It says, all chips down, is this more cool than economical? So what do you think? Is this more cool than economical? I don't think so. I think it's plenty economical. I mean, it's definitely cool.
I think it's plenty cool.
I think it's plenty cool, but I also think like
it's very economical.
Like
but
growing
it's also very, very cool.
Like growing a tank of THC and like swimming around in it sounds entertaining, but like also it sounds very valuable.
Yeah. I mean, very quickly it starts to get. I don't know. Sometimes my depends on what my day is like. Sometimes it feels more economical than cool, but
fair.
But it is still very, very cool.
Been there.
Yeah.
Like I mean, the number of days that I've been working on the spider silk thing, and I just want to like light everything on fire and just switch to gardening. Like, it's a thing. It happens. But no, okay, cool. So I mean, that was sort of what I expected. Like.
Oh, but one thing, just to quickly come back, I'll correct you on this. That the generic versions of a pharmaceutical product are supposed to be identical, like factually identical. I think what you're talking about is something called biosimilars, where it is like a slightly different modification and gets around these like patents, and then you end up with like maybe different effects. But I don't want people to start buying brand name drugs and necessarily changing the economy, but that direction's not like a good thing necessarily for
Well, it's also like
Just,
the main compound isn't necessarily the difference. Like sometimes in a generic, like the main compound is the same, but they might have added a different like filler or something that fucks with the exact behavior of the pill in the person. But I mean that's not to say that a generic is worse than a brand name. I mean, it isn't. I mean, I'm on a generic, and it works just fine. But there definitely have been cases of just I mean it's biology. As soon as you fuck with one thing, like somebody's system is gonna respond to it differently. So
yeah, and I guess there's another interesting area of like experimentation that's just around like, hey, like can we take like yeah, again I'll use THC examples. THC is available in like as a pill. You can get like THC pills under prescription, and it's a product that exists. It's usually used for helping people with appetite and symptom management when they're going through chemotherapy. You can also get something that's called Sativex, which is a product from a company called GW Pharmaceuticals, and that's like it's actually a cannabis extract that's I think CBD and THC together. Also available under prescription for the similar kinds of situations. And then just recently, there's a newer one that came out, which is actually a liquid form of THC, essentially, which is just like, I guess it'll get absorbed differently. It'll maybe react a bit differently, but it's all variations on the same sort of thing. And maybe in the end, this is better for consumers because you just have like all these nice options that you can choose from. And if you can't swallow pills, then great, you can take a liquid option, right?
and also, I mean, even with like speaking of THC specifically, like I know lots of people who are totally fine to smoke it, but as soon as you put it into an edible, they're like, nope, I'm done. Like they'll have like heart palpitations or whatever the case may be, like wildly different effects, even though it's exactly the same compound. Like that delivery mechanism really can radically change just the way your system responds to things, and I find that fascinating. I mean, it's
Totally.
not necessarily fun to experience it firsthand, but from like a detached scientist perspective, like no, this is fascinating. Apparently, if you deliver through one organ, it goes this and does that kind of thing. So like I find that fascinating.
Totally, yeah. And this, I mean, the crazy thing about the cannabis industry specifically, when you think about that stuff, is that you have so much experimentation already happening when it comes to like, the different edibles, different oils, different ways people are dosing themselves with this stuff, like both illegally and legally, I guess.
Yeah.
And that's what I mean, where things start to, yeah, a little bit backwards, where you have a lot of firsthand experience that's coming back and being put into like the pharmaceutical industry, maybe, and then people are developing products like as a reaction almost.
Yeah.
But yeah,
Yeah, I mean, like
fun system.
especially because it was illegal first, like
Yeah,
and the whole culture of it developed whilst it was illegal, and now they're trying to like back propagate that essentially. Like, I mean, I remember when like concentrates were first becoming a thing, and I mean, because like hashish has been around forever, but like the butane extractions and now the CO2 extractions and all this kind of stuff. Like we have lots of data on what happens when you interact with the plant, but we don't have a whole lot of data of what happens when you're like literally just taking in the pure thing. So that's been very interesting that now now that it's legal, they can actually study this shit properly, which really is
yeah,
what they've needed to do the whole time. And like I still think it was dumb that it was illegal in the first place. But like I hope that now, especially now that they're looking at other things like MDMA, ketamine, all those kinds of things, and looking at them for pharmaceutical or like from a pharmaceutical standpoint, like I think people are kind of learning their lesson from cannabis, in that like you really do need to like get as much studies done as you can, but because I mean inevitably it's going to be applied to millions and millions and millions of people. So getting as much of that info in advance before you have to find shit out the hard way is definitely valuable. So I think that's been fascinating.
yeah. So like everybody's learning a bit from how this is this whole industry is developing, and and this is like why legalization is also such a complicated thing, where like, yeah, sure, it's a statistically or whatever else, economically, you could think of all the different reasons, but also like the hope and dream was that you legalize cannabis and nobody gets hurt, right? But then in reality, maybe some people do get hurt, and then you have to, deal with that, I guess. And I don't know. I'm not an epidemiologist or like a policy analyst or whatever else, so I kind of I can talk about these things and not feel like I'm
Which I mean, and that's
too much responsibility about it, I guess.
Yeah. And I mean, that's the responsible thing. Like, I mean, there's nothing worse than somebody pretending they're an expert and then being wrong.
Yeah. Or like, I mean, there's actually funny, if you, I don't know, everything. So it's all super cool. It's all really interesting biochemistry. If you want to like, think another funny thing about, cannabis legalization stuff. I think one of the points that I remember being the age at which you're allowed to start buying cannabis in Canada was one of the ones that maybe was the bigger conflicting point, or people had more flexibility on how they wanted to do that. And that was like very much on one hand, I think the science was saying like not until you're 25, or like there's like a task force that got put together within Canada that kind of said like, yeah, we should set the age here. But then the federal government decided that actually it should be kind of either 18 or 19. And then of course Quebec I think is 18, and then other provinces are 19. It depends on how they match it up.
I mean, Quebec is trying to push it to 19. Actually, I think they wanted to push it to like 21. Like they really wanted to push it back.
Yeah, and actually, legitimately, that could be the right thing to do, of course. And that's why, like, task force recommended 25 or whatever, something higher, and then. But I think that might have been. I think one of the main arguments against that was that actually, a lot of the use cases of illegal cannabis end up being that smaller age range, anyways, and so you kind of want to be able to address that with like the legal market. Right. And then it becomes an economic decision rather than like a healthcare one. But
and also like if you try and restrict it to 25, like then you end up with the exact same problems that you have with alcohol or cigarettes or any of the other things. It's like, yes, technically it's illegal, but if it's available, people are still going to get it regardless. And like, I mean, and that's the thing, it was illegal for a very long time, and it's not like people who are like 15 or 16 have any real trouble getting it. Like, it's a thing. So, that's, I suspect that they probably took that into account as well. Like from a science standpoint, like, yes, you should avoid it until at least 25, so because it has, interactions with brain development and all this other stuff. But then from like an economic standpoint and also just a legal standpoint and a like functional standpoint, like how do you actually keep it out of people's hands? And like, because if you make it illegal and people are just going to get it anyway, like now you're just running head first right back into the same problems you had when it was illegal, where now you're going to criminalize people for having it when, like it's a kind of a personal responsibility thing, and also like they're going to do it anyway. So like, I think it's one of those, like, yes, you can put out the recommendations of, like, but you really shouldn't, but people are going to anyway. Like, it's the same sort of
thing. Maybe, yeah. It's super interesting, super complicated. But part of what it boils down to, and this is, I mean, it's a nice thing to say because we have, like, a big audience here, I guess. I can say, like, hey, when it comes to using this kind of stuff, or anything in general in life, just, like, try to be healthy, Yeah. Like, you probably... everybody has friends or heard of different kinds of people and how they use even like the more psychedelic drugs, and you can hear people using those things like really responsibly and having like experiences that make sense. But of course, if you don't do that responsibly, then you're gonna have problems, or there are obvious like situations that you really want to stay away from. Like you could easily argue that maybe actually. I don't want to say anything stupid now.
No.
But,
so
I'm saying, like, culturally, or like I would say, actually, wait. The good thing, the point that I can point to is like the difference between like the culture around maybe alcohol and in different countries.
Yeah.
Where in the U.S. it's a lot higher drinking age, in Canada it's a bit lower, and in Europe it's even lower. And then you have to think about which nation has the most sensible policy, and it might be more of a cultural thing where like the people in grow up with the right kinds of education and the right kinds of like understanding culturally of how to use alcohol safely or how to enjoy it rather than like abuse it, obviously. And the same thing to some extent applies to the cannabis industry as a whole. And I think that was one of the, dreaded things about people, legalization happening is like how many people are going to end up abusing this or using this the wrong way and having a really bad effect, and then they have to repeal everything.
Right.
And
which
so
is
fortunately
worse,
things haven't
and then like that causes
yeah.
all sorts of problems. Also, sorry, not to cut you
Yeah.
off. We just had a really big donation, so I just need to say a huge thank you to Jack Fourier. We've actually just hit our fundraising goal, so that's super cool. So on the next stream, we'll be starting the next one. Thank you so much. Greatly
Hey.
appreciated. I'm glad you enjoyed the channel. Okay, so back to the discussion at hand. Sorry, that was really exciting. I don't know if you, I mean, you can see it in the thing. The donation goals are I've finally decided that I need a new editing computer because I've been using the same laptop for like 5 years and it makes very angry noises when I'm editing. It doesn't like it. So I'm building myself a proper tower. So that's gonna be cool. So I'm just doing the fundraising like piecemeal because I want to get good components and I want to make sure that I don't have to do this again for hopefully 5 or 6 years. So doing that. So anyways, greatly appreciated all the people who've been donating, by the way. Super awesome. So yeah, very, very cool. So I'm gonna have just a quick peek into the comments because I mean I think we've actually gone through my whole list of stuff that I like, we pre-prepared. I don't actually, I think we've basically covered all that. So I'm gonna just go through the comments and see if there have been any interesting. And also, guys, if you have comments or questions that you want to ask Kevin, now is the time. So let's see what we got. Oh Jesus! This is as soon as you do that, like the like comments flood in faster. So like as I'm trying to like read one, the thing keeps moving on its own. Yeah. Okay, let's see what we got. I mean, it's been a lot of like bickering. I'm not actually seeing any good questions yet. All right, come on, like now is your opportunity of a lifetime. Ask the magical yeast man some questions. The thing is, I saw some earlier, so I'm trying to like scroll up to see if I can find them. I mean, there's definitely been some questions about like could other drugs be made this way? And I mean the answer is sort of a resounding yes, but it also depends. Like, you can't make LSD just because that's a weird chemistry. It just doesn't work. But you can make psilocybin. And there's been some very interesting papers. We were talking about this a little bit before we got the stream started, where you can totally make psilocybin with yeast. You can take the genes out of the fungus and express them in yeast, and it works just fine. But then it gets into the difficulty of the engineering process and a lot of that stuff. Oh, actually, there was one thing. It was so you're selling or you're looking to sell the derivative products, so the actual like oil itself. But have you considered just sourdough? Like, because I mean, then the yeast is dead. Like, no one's gonna be stealing your intellectual property if you're selling it as like toast. But is that something that you've considered? Like, or is it just?
I think there's some of the articles that we get featured in had like a picture of bread and then has like THC or the marijuana leaves on it or something like that to like kind of as like a header for like an article or something. Anyways, yeah, thought about this. I think you don't end up with enough yeast in your dough or in your bread in the end that it'd actually be interesting in any way. That's sorry.
So what about like Marmite? I mean, Marmite's gross, but it would do like. It's not to say that like, weed concentrate is any better. Like,
yeah,
is that something you're looking at? Like, rather than going through that like whole, much more difficult process of like purifying the compound, like, would it be potentially easier to just like make some weird THC Vegemite?
Technically, yeah, it might be easier to produce a yeast that way, but I think coming back to like the different processes to use things, I don't think you might get enough. Actually, let me think for a second. Anyway, the short answer is we've thought about this a bit, and at least a bit. But I think it starts to not work. Actually, it starts to break down when it comes to like maybe which yeast is actually used for these different things, and like, do we actually want to try and, will that Marmite that we might make with our yeast still taste as good as the Marmite that that one might get from. I it doesn't taste good anyways, right?
That's not really a hard
taste
call.
better,
Marmite tastes like shit.
But because you play so much with the metabolism of the yeast and the types of yeast that you're using, then you might actually end up in a spot where like it really doesn't make any sense to try and do that.
Okay.
And it might be even like fundamentally impossible to like have the metabolisms work, in such a way that you do end up with both scenarios possible, actually. And this is why also like you can't just throw this into like a beer fermenter and get the same amount of product out. You need maybe some finer control or different kind of growth conditions that are gonna really turn up those yields.
Okay, that makes sense. So here's an interesting question. I've been seeing some questions on like a biosecurity standpoint. Like, are you worried about the yeast ever getting out? Like, how are you going to be controlling to make sure that, like, nobody accidentally... Because, like, if somebody else got a sample of your yeast, like, they could totally make some. But, like, do you have... I mean, obviously, you're not going to have to comment on, like, the specific... What are the security features of your warehouse? And
yes,
what,
of course.
what is the
Where
code to the back door?
No, what's your address?
Yeah. But no, is this something... I mean, I assume this is something that you take fairly seriously and is something that is on your mind?
So it is something that is on our minds. Definitely thought about it before. If it were to get out, then I think there's it starts to get more technically difficult to grow this kind of yeast, and that's where I would be like less worried if somebody on the street like happened to get it. There's different. I could argue different reasons like why this like makes sense or not. In the end, we're just very careful with how we handle our strains of yeast, and we're just not going to let it happen ever.
Okay.
But I mean that we're only one of a bunch of companies working on this stuff, so maybe eventually there'll be somebody who does. Oops, sorry. Who does release it. I think it's a common question in like biosecurity in general, is like how does this work and what happens here or there, and maybe.
I mean, have you heard of the case of the phage theft? I think we might have talked about this at some point in months ago, but so there's this with, and obviously this is not a 1-to-1 comparison with yeast because they're not a virus. They don't just get on everything. But there was this really famous example of there was a lab that was working on a phage that killed a particular type of bacteria. And another lab wanted it and, had sent them an email and be like, hey, would you share? And they're like, no. So they sent them a physical letter, like an actual like written, like, please can we have a sample of your phage? And so because it was a written letter, they had to respond with a written letter. So somebody from the lab that had the phage wrote them a letter and was like, no, sorry, we can't give you a phage. And then the lab that wanted it took the letter, like, sterilely, blended it, and just plated it and got the phage because there was a little bit, like, just from the being in the lab, like, it was just ambiently present, and they managed to isolate it off of the piece of paper. So, like, that's wild. Right? Like, is that something that you might be concerned about, like, that maybe someone in your production plant might get some on them, and like, someone's like, hey man, I'll pay you $10 if I can swab your face or whatever, like, is because I mean that seems like it could be terrifying from like a security point of view. So I guess you'd, but then again, it's yeast, so unless someone's like sticking their hand in the vat, like, this isn't really like a problem, and you wouldn't do that anyway because it's got to be super sterile and all this kind of stuff. So yeah, basically yes. Yeah, it's not so easy to just like get it and then grow it and then you're off to the races. There's if you are a really really smart biotechnologist, then maybe you could try and like do something like that, but I think it's just
part of being a company and having really good security protocols for handling all this stuff and dealing with these kind of situations and thinking through it properly. So it's not like a something we haven't thought of or something that we're like, particularly susceptible to. Yeah, you could also imagine it sort of like the same case where like Humira or whatever is like this $11 billion revenue drug or something like that. Imagine if somebody stole the strain that produces Humira and tried to produce that, on their own. Probably the company that makes Humira will find out, and then also
and sue the shit out of you.
and then you get into trouble, yeah. But also you might just have like it might just not grow the way that it grows when we grow it, and then you end up with like it's not feasible to actually like get a strain that way.
I mean, and I guess they'd have to be intimately familiar with your process, because I assume it's on some weird selection agent with weird media and all this kind of shit. So like, unless it was like an ex-employee who like stole a sample and knew the recipe and knew, like, we're getting into like Willy Wonka territory. It's like, I will pay you $10,000 for a never-ending gobstopper kind of thing. Like, it's like, yeah,
Jurassic Park is like that, isn't it?
Yeah, right, exactly.
We all know what happened to that guy in Jurassic Park, right? Yeah.
I mean, the thing is, I have not actually seen Jurassic Park, so.
Oh really?
Which I feel very stupid, because like I for all the shit that I do, I really should, but I think it was one of those like, what's the best way to put this? I have a very low suspension of disbelief threshold, and that one doesn't, like, like the concept doesn't work, so like it's hard for me to enjoy it, because I'm like, that's not how that works. That's not how anything works. Also, like then there's and this has nothing to do with anything, but like the dinosaurs do not look like that. Like, all of the, which admittedly was an older, especially the original one was an older movie, so like some of the newer research where like most dinosaurs had feathers, like, hadn't been found yet, but I wish they'd had a big feathery T-Rex. That would have been so much more fun. Like, so yeah, that's the thing. But I know I'm gonna take a lot of shit for not seeing Jurassic Park, so now I'm gonna have to go watch it. Yeah. But yeah. Anyway, okay. So let's see what other questions we've got. I saw a couple interesting ones go by. I mean, then there was also a couple of questions from the like offhanded you can't make LSD thing. And the reason is that it, like, LSD is not a biological like the precursor is, so either like the ergot derivatives or LSA or all these other things, like those things can be made biosynthetically. They are made by lots of different organisms. It's that last step where you like take the precursor and actually like chemically transform it into LSD that you can't do. But I mean, as far as I know, I could be wrong. Maybe somebody's made some weird freaky enzyme thing that does it, but like as far as I know, there's no enzyme that does that last switcheroo. So you make the precursors, but you could totally make a yeast that makes ergot or ergotamine or LSA. It's just it's that last step that you just can't do. What else we got? So one question: why yeast over algae? Because algae is also something that's typically thought of as, being grown in these huge vats. So is there any particular reason why you would go for yeast over algae? Like, are there any specifics?
Yeah, I mean, I think we talked about it a bit about earlier, but it's kind of depends very much on like process metrics and also like the science going into like how you actually can engineer that organism. So, for example, like the yeast metabolism is fundamentally different from like algae metabolism, and you could argue that the yeast metabolism is more suited to producing these particular compounds because it has that active, those precursors that are needed to go into this pathway, for example. Assuming you could get an algae to do this stuff, which again, there's differences in how you how a yeast will react with like, being recombinant and having DNA in it versus how an algae would. And that's where like yeast is pretty reliable. Um, so after you've engineered the algae, let's say, then you can think about how you're going to grow that and how you're going to separate out your end product. And you know, if you think about algae, you're more likely thinking about like latent CO2 getting into to make it grow faster or better or whatever. And that's where like you start to hit some hard like physical limitations. You can't get more light into an algae tank. Like you can add more sugar and add more water, and that's like yeast you can grow really fast and get it to really high density cultures that are really efficient. But the algae situation can be more complicated. And then you could get into arguments like, oh, but you can grow algae off of sugar too, and then blah blah blah, and then
Right.
I'll leave it at that. Like it's process. Yeah, it is a process in the end, and yeast is a pretty familiar process and a very efficient process, and a very ubiquitous process. And then algae maybe like less so.
Okay. I mean, and that makes sense. Also, from what I know, like just the actual engineering of algae is more difficult. Like, it's they're just they're picky organisms, and there just hasn't been like yeast has been extremely well studied because it's used for pharmaceuticals and all this other stuff. Like, there's literally textbooks on all these different kinds of yeast strains on how to engineer them and how to work with them and how to grow them. Whereas algae, like we're good at growing it, but actually like messing with its genetics is hard, and just things don't necessarily cooperate. Um, so, oh, so have you looked at all at terpenes? Because you've got the THC. Have you thought about growing the the flavor to go with it, or are you more focused on the actual like pharmaceutically active compounds?
Definitely more on the active compounds there. Although some of the terpenes are starting to maybe show some promise in terms of being actual pharmaceuticals too.
Okay.
But that also, like, those are different pathways that are going to be different. It could be made more easily by chemistry or extracted from another natural source, and then it becomes there's already maybe a process that exists for some of these ones as well. Like I think limonene maybe is one of these ones that like limonene is you can just buy it. It's industrial chemical. It's
Also lemons.
I forget if it. Yeah.
Like
Um,
we have lemons. There's
Yeah. So you don't need a yeast that can produce limonene, maybe.
Right.
Or you could argue that and work out the economics
I
and figure out if that
have
makes
a
sense.
plasmid that does that actually.
Okay, there you go.
Although the only reason I haven't tried it is because there's no. I think it uses uracil dropout media as the selection, or like dropout media with No, yeah, it's uracil dropout media, so it's missing uracil, and I just don't have that. Like I don't have dropout media, so it's the only reason I haven't tried it. Because like all my yeast engineering tends to be using G4 just because it's easy and G4 is cheap, um, and dropout media is expensive and annoying. Um, Although actually, so I bought some tryptophan dropout media. I didn't even want it. I wanted it came I got it as a kit from Carolina. Um, they sell their bio builder kits. One of them is a keratin yeast kit, and I just wanted it. I thought the kit came with. This was actually really frustrating. So the kit was supposed to come with pre-engineered keratin producing yeast. And that was the only thing of the kit I wanted. They don't sell it separately. You have to buy it as the kit. So I bought the kit. And then the one thing that was missing that they forgot to pack was the pre-engineered yeast.
Oops.
I was so annoyed. But it came with a bottle of tryptophan dropout media. So I'm like, all right, well, now if I've got anything. So I found a plasmid that's Cre recombinase. And the keratin plasmid that I currently have has LOX-P sites next to every single gene. So if I take my pre-engineered yeast that I've already managed to make, and I, throw in the Cre plasmid, which is on tryptophan selection, I can now use that media to make like an integrated version of the thing. And then I should actually get like really weird like color differences, because depending on which one of the genes is running, and in what quantity, like you'll get different colors. Like if the keratin synthase stops working, but the lycopene synthase is still working, you get a red colony. Whereas if you've got both, they look orange. Whereas if you get really low lycopene and really high keratin, it looks yellow. So it's all this kind of stuff. So that was just something that happened recently. But like also it's a very interesting thing of like when you've got when you're trying to make a product that requires more than one enzyme, like it's very interesting to see the dynamics between them. So like especially with something like THC where you've got anywhere from 4 to 8 to 10 enzymes that you all need running at the same time, like your yield can vary wildly just in small changes in the expression and like tweaking the individual enzymes. So I think that's really fascinating.
Totally. If you want to, violation is an interesting one. I think that's another one of these proof of concept kind of pathways that people like to play with because it makes a purple color, and if you mess it up, then it makes it black instead. And then you play with the enzymes a bit. Yeah.
Cool. And so I'm not really going to get into like talking about the specifics of enzyme engineering, but I suspect that you have had to do a little bit of that. Like the natural enzymes maybe aren't as active necessarily, especially in yeast, right? Like they're plant enzymes for a lot of them. So I assume you've had to do some work. And I mean, you don't need to go into the specifics, but like, what has that process been like? Like how do you go about that? Like how do you decide, like, this is the enzyme that we're going to mess with? Like, is it done rationally or is it done randomly? Like, do you just kind of like start messing with aminos and seeing like which ones, like which end up with an enzyme that works better? Or is it something that like you find in research and you just try and replicate that?
So it's more like the, I guess, rational and irrational approaches on doing enzyme engineering stuff. I would say like, what we have done is built like a really efficient way of going about doing that. And that we're pretty happy with. I would say like our genome engineering and our enzyme engineering platform is really nice. And that's I'm like that's all I can say. We're good.
Okay.
But yeah, I mean that's the it's an interesting topic to kind of get into, like different techniques of enzyme engineering that you can look at and how. I'm trying to think if there's any good publications on this particular pathway in general, or if anybody's really dug deep into that. But anyways, yeah, getting a bit more technical there. But yeah, enzyme engineering is fun. We do it pretty well.
Okay.
Yeah.
So and I mean you can not answer if this is something that you shouldn't talk about. But do you spend more or equal time messing with the enzymes in the pathway, or have you also started looking at messing with the metabolism of the yeast generally? And I this is definitely something we've touched on a little bit, but like is it a lot, like, do you really have to go in and seriously tweak the metabolism, or do you more focus on just trying to make the enzymes themselves in the pathway you care about better?
It's a bit of both, and a lot of like maybe crossover between the different teams that are working on this stuff, I suppose. Yeah, what should I say about this?
Well, so actually, I mean, that do you have different teams in your company that like focus on the different aspects? So like, one group works on, okay, so you've got like a metabolism engineering group, an enzyme engineering group, that kind of thing, and then presumably like process engineers and that sort of thing.
Yeah, totally.
Okay, cool. How many people do you, how many people do you have working at your company now? Like, because I mean, I know when it started there was like 3 or 4 of you, but like it's grown quite a bit.
Yeah. We were at about over 20 people leading into the month of March, and then businesses were asked to shut down and stuff, and then we've made some like changes to our team since then, I guess.
Okay.
But that's
Actually,
Yeah.
Okay, so about 30 people. Cool. Actually, that brings up an interesting question. How has the ye old plague affected your ability to do the thing? Like, has it like interfered with the research? Has it interfered with production? Like, how are you handling that? Because this is, I mean, your business is very different than like your average retail business, but like it's got to have been affected. So like, how has that been handled?
Um, it's uh, it's been okay actually. I'd say like so. Um, sorry, just thinking about something else for a second. Um, we it's been hard because like we're kind of a smaller company that's funded from like investors and stuff like that, and so a lot of like the support and a lot of like the way the government was like funding things, like supporting stuff, didn't really apply to us right away. In the end, we do have enough money in the bank to kind of like lead through the stuff and still make some like really interesting achievements over the course of the past few months. But so I would say some hard stuff to deal with. Being
Fair.
a CEO at this time is like a pretty challenging kind of,
Stressful,
I think
I
I think
assume.
anyone leading companies through this period is like under a lot of pressure. But as a whole, I would say like we've handled things like reasonably well, and we're doing okay.
Okay, fair. So actually, I think this actually leads into another interesting question. Let's fast forward a few years. Let's say you're already at the point of scale and production, and you've got a product on the market. Um, how differently would your company hold up in the case of a plague event or serious shit happening, compared to like a more traditional farm? Like, would you have an easier or more difficult time?
Um, Easier,
Okay.
I would say. I mean, if you depending on hypothetical plague in the future, like what might be run into
Yeah, the
next? What's
next
coming
one.
next? Oh
Yeah.
God, how's it going to transfer? But I guess if you think about like managing a production plant that does like yeast manufacturing versus having to like trim cannabis flowers, like there's interactions that like you don't never have to touch the yeast if you're doing this kind of manufacturing ever, when it comes to doing this at large scales. And so in that sense, and you don't need as many staff to kind of run like a big facility like that, compared to the number of staff that need to like watch over the plants and make sure that they're all growing the right height and everything like that, right?
Right.
So I can think of all these different reasons why it might make more sense to in the future.
Because I mean, it could be more
Make
automated, right? Like, I mean, if you're just processing yeast, it's just liquid handling basically, like,
yeah,
and so you
that
could
kind
have
of what
like,
it boils down to.
right. I mean, it's you're handling liquids and goo. Whereas if it's a traditional farm, like someone has to harvest all the plants, someone has to trim all the plants, someone has to package all the plants, and so it's also more hands-on, especially in the age of, hey, maybe you don't want to be touching things. um, so maybe like at the end of your process, it could be mostly automated, and you just get like a 55-gallon drum worth of concentrate at the end, versus when it's plants, you still might get a 55-gallon drum of concentrate, but there's a lot more people involved potentially, right? So that about sum that up.
Yeah, basically.
Okay.
I mean, one day we'll have robots that will farm all of our plants too, and then maybe it doesn't matter anymore.
Although, I
Right?
mean, yeah, but farming robots are hard. Farming robots are
Yeah.
very difficult, and they're very expensive. And I mean, when you compare the difficulty of a liquid handling robot on an industrial scale versus some robot that has to like understand and interpret the shape of the plant as it's trimming it and harvesting it and working with it, you know, getting its pokey bits up in the plant's space, like that is a much more difficult engineering challenge, and like even just computer science challenge. Like, how do you teach a plant what a plant, or teach a robot what a plant is supposed to look like, and all this kind of stuff, and then properly interpret all the signals so that it handles it properly, and have whatever grabby arm thing that it's a more difficult challenge, and it's more expensive, and it's probably more parts. Whereas with your stuff, because it's all just liquids, like it's just turning valves and shit on and
It's
off.
a big tank of stuff. Yeah, yeah.
Yeah.
Drains fast.
right? Like
whatever. You
drain it into the
pipe it
next
around
tank,
wherever you need it to go.
right? Have that
Yeah.
tank get hot. That tank is cold. You know, spin. That one's a centrifuge. That one's solvent. Whatever the case may be.
Yeah.
So that's very interesting. So it's theoretically more robust. So I think that's also an interesting prospect for both. I mean, other pharmaceuticals, but also just whatever other end products and cannabinoids and other things that you end up making. Like it adds a layer of robustness in the face of the world shutting down. Which
Yeah, and this is the heavy hitters of the Syn Bio hype circle are all in favor of this kind of thing, right?
Right.
Or like grow yeast in space, and then you can do it that way too, right? And then you don't have to
That's
produce
true.
anything you want using
That is very true.
yeast instead of growing plants.
Do you look forward to one day sending some stuff up to the space station? See if you can have a teeny, like a little, like petite, like the like the rack mount units they've got on the ISS. It's like, and this is our stove or
Oh yeah,
oven.
yeah.
Do you imagine just having like an itty bitty one and just like astronauts vaping in space? Like.
Maybe not the astronauts vaping in space or something. I don't know what the relevance of that to you. Actually, I wonder if there might be something there to
Hey,
check
if
out.
if you gotta wait 6 months, in the void of space going to Mars,
Yeah.
you gotta have something to do.
Yeah.
Like,
Yeah, somebody's but actually bone development and degeneration. Maybe there's something related to the endocannabinoid system there, so you might actually have a therapeutic use
there you
for
go.
that. But
astronauts
I
getting
did
high
I did
for
come
science.
close.
I like it.
No. Come on.
It's your safety vape.
I mean, maybe the astronauts really do they want this kind of thing up there? Do they even? I don't even know what it's like to. Anyways.
Oh man, well, because they get like weird issues with like CO2 pockets, so it's like you'd end up like if you like hotbox your quarters, it just might just hang there for a while.
Oh
like,
god,
that'd be so weird. Oh man, that would be so weird. Okay, that's. Cool. I mean, so have you? I mean, this has really nothing to do with anything, but like, have you thought about the physics of growing pharmaceuticals in space? Because like you're like, it's fine when it's a tank of liquid on Earth, like you've got gravity to hold your shit in place, but like, I feel like that would be a huge engineering challenge to make that work in space. Like things would slosh around and just float in weird. Like you'd have to like get the tube into like the center of the liquid somehow, just to like, I don't know. I think geometrically it would just be a very interesting challenge to like deal with the fact that your liquids don't sink.
Yeah, I haven't really thought about it actually.
Yeah, I mean that's fair.
Although I came pretty close to actually this. There was a competition that was going to be related to some like getting our yeast strains into space as like a research experiment somehow. Mm-hmm. Anyways, that was like years ago that I tried to do this thing, but there is some interesting stuff when it comes to microgravity and yeast and other microbes and how they grow and also other stuff. Mm-hmm. I guess there's work to be done and interesting things that I guess all organisms kind of change when they end up in that environment, even humans.
I mean, it's a radiation environment too. So you'd have like this is something I've been thinking about. Like if you try and grow your pharmaceuticals in space, like it's a heavy radiation environment. You have a mutation and it's gonna fuck with your product so bad, like it could wreck your batch really really easily. I mean, there's been a lot of experiments where they try and grow bacteria in space and they get angry. Like they do not like it. Like they mutate really hard and have really nasty products start being produced, and it's very strange. It's entertaining. Yeah. I mean, from a science perspective, it's fascinating. But like, I would not want to be the guy in charge of that. Oh man, have they done slime mold in space? I feel like they did, but also if they haven't, they need to, because that would be such an interesting experiment.
Yeah, I wonder. I haven't looked into it. What else? Yeah, space is weird.
Space is weird.
All weird stuff.
It's very weird. I like the idea.
We'll get there
space.
Eventually, but like, yeah I guess we gotta figure out.
I think
still figure out better ways to get.
I think moon base is probably where a lot of this stuff is going to end up happening.
Yeah, true, maybe.
Because I mean, that's like, sorry, like fuck Mars. Like the moon is where it's at, and like I think Mars bases are stupid, but I'm a huge fan of moon bases, just because it's close and it's just a very fascinating thing. But I think, I mean, also there's enough gravity that like your liquids would still probably slosh around in really weird ways, but there is still enough gravity that like a tank of liquid will settle.
Yeah.
And so like I think being able to grow pharmaceuticals in the way that you are will probably be very valuable technology on the moon. I almost wonder if that's like, because I know there's grants and stuff for moon projects. I almost wonder if that's something that would be worth like you considering, like just see if you can
You
get
find
some
me a
like.
grant, I'll try it out. I'll apply for it. Why not?
All right, fair enough. I'll see if I can find you
We can get
some
up there,
moon
yeah.
grants. That'd be entertaining. Just like moon weed. Oh fuck yeah, that'd be fun. But no, I think like long term, like being able to, because the only time like that sort of base would really be stable and viable long term is when you can produce all your own stuff. And like pharmaceuticals, I think is going to be one of the most difficult to produce because each pharmaceutical has its own quirks. But I think if you had like 100 tanks, each one had a yeast that produced some different useful thing, like that seems like a really viable way of overcoming that problem. In this, because it'd be like technically easier than trying to do chemistry in space. Like,
Well, there was that I think it was Craig Venter that was the one that kind of suggested like, oh, why don't you put like a DNA synthesis robot on the moon that just like spits out DNA, and then you don't even have to have a yeast collection of yeast there. You just have
right.
the DNA being synthesized, and then you
Yeah, and then presumably all the
synthesize life from
biologists went,
scratch.
that's not how that works. Like,
Yeah. Or something like that. Anyways,
yeah, that's
I guess you could imagine like having a basic yeast strain, and then you're transforming it with different pieces of DNA, and then depending on what you give it, then it'll make a different product, right? And then you don't have to have
right. No,
a
I mean
library.
in
But
theory that sounds good, but as someone who's actually done like a lot of, you know, toiled away at yeast transformations, I'm like, it's not that easy. Like, like
yeah,
it sounds really good on paper. In practice,
no, but
uh,
this is later in the future when we
yes,
have a
yes.
synthetic version of yeast that actually takes a
Oh,
DNA and does it
oh
all
yeah.
properly.
Oh, that.
Just
Oh yes, sure,
it's
great.
yeah.
Yeah,
So first that, and
can
then you have
somebody
the
make
kind
that
of
yeast strain now? Can I have it, please? Like, I want magic yeast that makes my life easy. Fuck. I mean, like, forget growing THC. That'd be way more valuable. Just magic yeast. Just
yeah.
can make anything. That'd be fun. Okay, so let's see if there's any other questions. But I mean, we've been going for 2 hours. So like, if you wanna, if you're ready to wrap it up, then we can do that. Let's just see if there's any other interesting questions really quick. I'm just gonna like skim through. Not really seeing anything. So yeah, if anybody's got like a pressing question, speak now or forever hold your peace. We'll give you a minute or two just because I know there's lag on the stream. So yeah, if you got some questions, leave them in the comments and we will try and address them. But otherwise, this has been fun. I'm glad we finally did this. I think this has been a really interesting conversation. We got to cover some really interesting ground. It seems people have been enjoying it, so that's been good. Yeah, I think there's a pretty significant lag on the stream, so it's going to take them a second to actually start sending some questions. If they do that, otherwise they're probably just going to continue bickering amongst themselves, as this usually goes. Okay, so there was one question: the stability and reproducibility versus like a cannabis monoculture. So like, how's that compare?
I mean, I don't know that much about cannabis monoculture, I would say, but like, I think, like for yeast, it's no problem. It's easy. You do it all the time. Like it's just part of the game. For cannabis, I think there's a more specific things that you have to do in order to get it to, grow consistently and to do that. For I guess you might be thinking about like 20 years that you're producing this like same exact plant in the same exact way. To make the same exact compounds for somebody to use for therapeutic whatever, and that's I think some companies that are doing more of the pharmaceutical aspect of this stuff are like, working towards that, or have at least spent a lot of time like mastering that one aspect of it, like growing cannabis consistently. And then, but that was like, I think that was a big challenge earlier on in the cannabis industry, and it still is hard to get like, uniformity across like every cannabis plant that you grow, just because of the different conditions that might tweak it a little bit.
Right. Okay,
Yeah.
that makes sense. This fucking guy. Will you be doing an IPO? Like at some point, are you looking at taking the company public, or are you going to stay private for the foreseeable future?
Yeah. Good question. We'll see.
Fair.
Yeah.
Well, when you do that,
No,
let me
I
know
mean,
so I can buy some stocks.
it's a question of, yeah, of course, right? A lot of, I mean, that's like the whole startup story, right? Like, where do you end up in the future? And it's like, hopefully you find a way to make the company exist and actually make it like into a hugely successful thing, and then you can decide if you want to sell it, or if you want to continue doing it, or if you want to take it public or whatever else, right?
Right.
Yeah,
I mean,
all
that's
possibilities.
fair enough. This I assume this is something that you'll only be able to be like yes or no. But do you do computational analysis to predict the structure of better and more efficient enzymes? I think we talked on that. We talked about this a little bit, but like.
Short answer is yes, yeah. But I guess generally speaking, I did a bit of this work in my undergrad about like how to use computers to predict stuff with enzymes, and it gets to be pretty, like despite many years of computational enzyme discovery and prediction and design and whatever else, I would say that the results from computational predictions are like pretty limited. Yeah. So even the best people in the world at this science technology of like predicting protein structures are still having a hard time with a lot of different cases.
Right. I mean, that's sort of what I expected. Like,
but anyways, yeah, it's a cool topic. I love the topic of computational enzyme prediction. That's super cool.
It is super cool. It's just also enzymes are hard. Like,
yeah,
and also things that we think will work don't often. So like a lot of the time it's I've got this great idea, and what if we just tweak this one thing, but then you just like mutate it randomly, change something that makes no obvious sense to you, and it just ends up working way better. You're like, okay, what?
Right.
So it's like, okay, cool. There've been a lot of questions like, are there internship possibilities at your company, and also like just asking about your hiring practices. Like, are they mostly like PhD and masters or people with PhDs, masters, that sort of thing, or do you have kind of more of a open range?
More open range actually. I think we've got like a good mix of things, and we don't necessarily. I mean, we have some philosophy where it's like we don't necessarily want to hire a PhD to fill like an entry-level role. Of course, that's going to be more like a bachelor's or master's student that will fill those kinds of roles. So, every role has its place. Every person has its place at our company. So,
yeah, I mean, that's fair enough. But so you're more looking for like talent and skill set rather than like magical piece of paper.
I'd say generally yes. Yeah.
Hey, no, that's fair. I'm all about it. That's good shit. Okay, that question's already been answered like 100 times. Okay, what else do we got? No, okay. I'm not seeing anything particularly interesting, so I think we'll probably wrap it up there. Well, either way, thank you very much for hanging out. This has been a lot of fun. I know we've been trying to set this up for a little while, so I'm glad we finally got it done. It seems like people really enjoyed it, and I mean, I think we got to cover some really interesting ground. I mean, I learned some things. This was really great. So yeah, thanks for hanging out.
Cool. Yeah, this was fun. It's a pleasure. Hopefully, people learned something from this the exchange here.
Yeah.
And
If
otherwise,
people have
yeah.
questions, is there a spot that they can contact you, or and do you have any other? I mean, there's the Hyacinth link in the description, but is there anything else that you want to plug while you have the opportunity?
Good question. I don't think so. I think just follow that link. If you want to uh, hang out with other people who like to do DIY bio stuff, and you can go check out Brico Bio, I guess. That's brico.bio. And I think the website's out of date now, but I'll update it maybe. And then in the future, when people watch this, they'll realize like, oh yeah, this is cool.
Yeah.
Otherwise, yeah,
Okay.
they can send questions to you, and I'll answer them through you. Maybe is also another approach to that.
Fair enough. Is there
How
a
about that?
contact page on Hyacinth, or is it
There is,
okay?
but we're usually pretty slow to answer that, just because like
Okay. No,
depends on the
hey,
question.
that's totally fair. All right. Well, either way, thank you very
Yeah.
much for hanging out. This has been a lot of fun. For the regular viewers, the next stream should be on Monday. I think we're just